Okay, yeah. Continue, please. Yeah.
So, and these lines from 15 to 24 is related to graphics. So this is the screen width and height, and for red, green, and blue, we have four outputs, and this is going to give the address or screen width, the address width for 640. Okay. So now let's go
Wait, just
and look
Peter.
at the
This is louder.
laptop. So again, we have to complete the laptop. That is a
Okay.
file that should be completed. And here, what we have to do is first have the VGA controller present in this board specific top module as well. So here we are trying to have a separate controller outside the laptop design, and we have all the peripheral controls in the board specific top module. So the graphics, that is your VGA controller, is present here. So you can have a look at, this is where the VGA is instantiated, and this is your VGA controller in the peripheral folder. So here we have horizontal and vertical constants, and this again, that's how a VGA controller would work. You have the horizontal sync and vertical sync, and the number of horizontal lines and vertical lines. So that's a different topic. For now, we just look at how the VGA is instantiated here. So from the boot specific top module, we have to provide the head sync and vsync and the horizontal position and the vertical position to your VGA controller. And from where are we receiving these data? So we can look at line 169 and 170 where x10 and xy is x is assigned to x and y. Now, where is this x and y coming from? Now let's look at the laptop module. And this is where we are getting X and Y. And we also see something called VGA red, VGA blue, and VGA green. So let's see what are these signals. So let's go back to the labs folder, and we are going to look at the graphics, and we'll be looking at the first design where you will be displaying a rectangle. So let's open the laptop, and this is generating the pattern for your X, Y, and your red, green, and blue signals. So you can see a wire, and you can see the red, green, and blue that is being declared assigned to 0 here, and you have a combinational logic. And you can see green getting assigned based on X and Y values. And here again, you can see red and blue. So from the laptop, you will be generating the design patterns and the X and Y positions. So what is the position and what X and Y values will be displayed in that position. So that will be again sent back from the top module to the board specific top module that is here. And these signals will be connected to your VGA controller, which is instantiated here. And here it's important to remember that you declare all the signals here, like X and Y and headsync and vsync. And we can look at the input and output here. We have headsync and vsync. That's the output from the board. So that means you have a pin on the board where your headsync and vsync will be connected to. And similarly, your VGA red and blue, that is again will be the output for the pins. And X and Y, so this is a signal that I missed when I was trying to complete this, because X and Y was declared here as a wire. So in Vivado, this will be taken care of, but it's important to remember that you declare X and Y, and this is declared right here. So that is the screen width and screen height. So these are changes that you have to make for the first design or the first lab for graphics. And if we move to the second lab, we when we look at the laptop, you can see we have game top here. Let's look at another file. So this file will be game top. And you can see your VGA is declared here in the game top module. So the VGA controller is declared here. Sorry. So the goal is to remove the VGA controller from the game top module and place it in your board specific module. It's already spaced in the board specific module. So we have to make sure that we pass the right signals from the game top module to your laptop module, and from the laptop you send those signals to your board specific module, and from there it goes to your VGA controller here. So your your heatsync, vsync, and your XY and red, green, and blue. So these signals should come from your laptop, and if it's not present in the laptop, look into the submodules, and the submodule here is the game top, and when I look into the game top, it's somewhere here. So these signals should be sent from game top to laptop to your lab specific module and eventually to your VGA controller. So this is the next changes that I think everyone has to make, and I think eventually I will also be working on this. And any questions?
So let me make some note. Now Kieran shows how to move like a VGA module from a game top. So this is through 3 levels of hierarchy. But in our case, like I already moved VGA module through 1 level of hierarchy. Like in example, ellipse, rectangle of parabola. So in two graphics, like first lab, like a two one lab. So like I moved it already. So you don't need to modify anything in your like anything for you except for one file. This one is the external file. Okay. So you need to modify only a board specific top for your board. In this board specific top, you need to put VGA controller and hook up wires with VGA controller and your laptop. Yeah, this is only one thing you need to do. Because Kieran is talking about some like additional actions. He's talking about changing game top. Changing game top is the next step. Okay, so Kieran, please continue. Oh, wait, Kieran, you cannot hear you. Can you hear?
Can you hear me now?
Yes, you can hear. Okay. So can you make font larger?
Yeah.
Oh, pardon me. I turned it down while Yuri was talking.
Yeah. So it is also necessary to read your board specific XPC file also. So this will show you how the ports are connected to the board. So this is again for the Nexus 4 board, and we can look at the graphics. So let's look at the VGA pins. Yeah, so we can see the VGA connector here, and you can see the VGA red as 4 pins. So that is declared here, 0 to 4, I mean 0 to 3, which is 4 pins. And similarly blue and green, and heatsink and VSync is connected here. So sometimes if your heatsink and VSync is not declared, you can read the board specific board file as well. Sometimes you don't require heatsink and VSync. Sometimes the VGA red will be 8 pins, or for this board it's 4. For some other boards it might be 8. So we can see how it is connected here. How it is connected to the pin of the FPGA board. So these are the changes that I made to make the Zybo board work and the Nexus 4 board work for uh, the first design. That is the basics. The first, let me show you. I think it is G. We can go to labs and yeah, the basics. Yeah. So these are the changes that you have to make. So your main changes will be in your board specific top module. And once you make changes to the board specific top module, make sure all these basic designs work, and then move on to the second part, which is the graphics. And for the graphics, bring the VGA controller in the board specific top module, and then make sure your first design works, and then move on to the second step, where in the game design your VGA controller is in the sub modules. You have to bring that out and place it in the board specific top module, and then make sure the signals are passed to the VGA controller so that it works correctly. So any questions till here? Any questions of how to instantiate or how to read the signals? Any questions?
So Kieran, if you're done, I can actually make a short version of it just by deleting the
Sure.
file.
Yeah.
Okay, so now let me make a short version what has to be done. Okay. So yeah, did it stop shit? Okay. Okay. So step number 1. You need to get your what's so strange. Wait, somebody else is showing screen. But this is not on my screen, right? Ah, no, this is my screen. Everything is okay. Yeah. Okay. So now let me close all the unnecessary things. They will show only in GitHub. So step number 1. You need to get a board and you need to run synthesis with the main branch of the repository. So let's get the repository basics graphics music. So you start to run with the main branch. So in this way you check that your board actually works. And you need to connect this VGA display, which I have, or you can bring some additional VGA displays from there. And first we check that your board works with the main branch. Once it works with the main branch, we establish baseline. After that, you need to switch your branch to new graphics. So you switch branch to new graphics. Then
we need to first we need to comment on
you can clone new graphics in the new area if you want.
Yeah.
But you can also just do a git switch in your repository. So what you can do is Let me show you command line. Oh, I can show later. Let me show you just the changes. But what you can do is that you can do git switch new graphics, git fetch new graphics. Huh? Yeah, you can do git check out the new graphics. Yeah, this is the best because it does both fetch and switch. Yeah. Now, so now let me do changes which Kiran did and which I verified. This is changes in board called Nexus 4. So the only one file was changes this one. So now I will show you changes in this file. Because this file has only one commit. No, it has multiple commits. So let's do okay, remove tabs, Nexus. So let's get the last commit. Okay, but actually this was done in multiple times. Let me do diff in this case. Okay. So what I will do is that I go to projects. I go to projects, basics, graphics, music. So this is git branch. So right now we are on new graphics. Okay. So now I will get the boards Nexus 4, and this board specific top, I put it in file like Z2, and then I do git switch main. So now I can just do tk diff board specific and Z2. Okay, so you can now see my diff. So let's see the changes I did. So first of all, we need to change file lab specific config into lab specific board config, because this is change in header file I did. Second, wait, no, this is actually all the change. Sorry, I need to do git pull. I think I didn't do git pull here. No. This don't is micro USB. This just I will help you. Just let me finish with this. So first I need to do git pull in both repositories, then I git switch to main. Wait. First we do git pull, and this is the old repository. So this we call 01. Then I do git switch to new graphics. Okay, and now I need to do git pull, so I need to get all my changes. Okay, now I copy this into Z2 so we can compare these files. Okay, so now there are much more changes. So I'm diffing file called board specific top.sv. Board specific top.sv. So here what has to be done? first of all, we need to add actually let's not do div this way, let's just do it in the editor. Yeah, so first of all, you can see that you need to add additional parameters for the board. This parameter is screen width, screen height, and number of bits per channel for graphics. So this is first change. Yeah, also there is such thing as a pixel megahertz, which is a parameter for display, and for all boards we are talking about, this is 25. So VGA normal frequency is 25 megahertz. So you just need to get a header from Nexus 4, use it as a sort of example. But then you need to realize that you have different number of keys, switches, and LEDs on each board. So this part should be the same as it was before. So you're not modifying this part. So you will need to insert this additional parameter. You need to insert screen width, screen height, red, green, blue. And then you also insert parameter for widths in bits of coordinates. So because this is coordinate X and coordinate Y. Okay. So second difference, then we go to the list of ports. List of ports is practically the same. So list of ports is practically the same, except for cosmetic reason, I inserted here not like absolute number, and absolute number is 15, but number of WSW, which is the number of switches, which is 16 switches minus 1, 0, and WLED minus 1 is the number of LED. So I just did it more like a parameter list. Yeah, rest of ports are the same. Then I did the same thing for parameterization of red, green, and blue. So we have on this board 4 channel red, 4 channel green, and 4 channel blue. Yeah, that's it. So no more changes. Now here we put wire for reset based on board specific reset. So no changes here. And then when we go to signals connected to peripherals, yeah, this is something what we don't need. So we put 2 additional variables. One is wire X and another is wire Y. We need to put additional wires because as I explained here, instead of making this wire local to a laptop module, I put this wire outside. So I moved wire X and Y outside. This is the declaration. This is the significant change you need to do. So Kieran didn't do this change and it didn't work. Because if a synthesis tool does not see wire declaration, it may assume this is only 1-bit wire. It's a 1-bit wire. Okay. Next step is that you need to modify a laptop. So it was before top and it became laptop. And in this laptop, you need to propagate parameters for screen width, screen height, and the number of bits in each color channel. So in color channel red, in color channel blue, in color channel green. Okay. So next thing, we need to propagate wires for X and Y. So we need to propagate wires for X and Y from board level into a laptop level. So X and Y. So we put this wire. We connect the wire in board specific top to the something inside laptop. It's the second thing. Third thing, we need to remove propagation of wires H-sync and V-sync. So H-sync and V-sync, those are wires specific for VGA interface protocol. Okay. Because of like other types of displays like LCD and HDMI, we have different protocols, we have different wires. So we don't want user to see it. So now, rest is So next, here this board had only microphone. But here we need to instantiate graphics display. So module for the graphics, VGA. This is a third major change we have to do. Then I also instantiated here a module for sound output, but this is next step. So now let me summarize it again. We need to do the following changes. So let's put file existing and let's do changes. First, we need to add additional parameters. So add additional parameters. So and we add them. So which is screen width, screen height, width of channel red, green, and blue, and WX. So this is like first change. Second change. So here, if we want to like parameterize signals, we can do it, but this is kind of optional. Second thing, we need to add declarations, wire declarations for X and Y. So this was like step number one. This is step number two. Add wire declaration. Second. This is the second thing to do. Now, once we add wire declaration, we need to change module instantiation, change parameters in module instantiation. We also may need to change top into laptop. So change module name. So change instance and module name. Change top to lab top module and instance name. So it was top, now it is laptop. And and propagate parameters for screen width, screen height, and propagate parameters for for graphics, because user need to know how many colors he has and what is the screen width and height, but user does not need to have a pixel megahertz of parameter. So remove pixel megahertz propagation if present. Propagation if present. Okay. Now, so this stays the same. Okay. Step number 4. Remove. So add instance port connection and for remove interface level like VGA specific signals from port connection to laptop instance. So we remove this vsync hsync. So this is something. So this is something we have to remove. And this x and y is something we have to add. So we need to remove this one. Done. So now, once you do it, this whole thing is supposed to work. This whole thing is supposed to work, and once it's working, you check it into your fork, and then you make a pull request. 5 steps. So now let me get this file and send it to like everybody. So I will now email it to everybody. So what is the name of editor here? Forgot. Oh, wait. You can use the call. Yeah, so let's send this file to everybody. Let's do it. So let me send it to NetSV list. Okay, so I sent to everybody the file. So you should get it in your email, and then you should look to your board specific top module and apply those 5 steps. And hopefully by doing this you understand mechanics of instantiation and how wire hookup is working. So now I expect everybody. So Philip, Mike, Alex to do the same thing. So Philip, so do you understand the thing? But actually we did this already for D10 Lite. So for you task is different. You need to hook up the thing with wires to make a game working. So let me show you the problem. So yes, Philip, can you hear?
Yes, I can hear you.
Yeah. So you see, there is this game test called two graphics game. So now it is broken. So you need to put some wires around to remove a VGA module from game top. So you need to remove this instance from game top, and you need to hook up with X and Y wires, so that game top is getting X and Y from top level board specific module, and generates RGB. It does not generate H-sync and V-sync, and everything should start to work again.
Hello, Yuri, are you sharing the screen?
Oh, no, I don't. Sorry, let me share the screen. Okay. So now you see there is this test, two graphics, two game. So you need to change game top here. So you need to remove output H-sync, V-sync, and you need to add inputs X and Y. And you need to remove instance of VGA module from here. And you need to get X and Y, to propagate X and Y into a game top module. And after this, game demo should start to work. This is like a task for you. Yeah. And with the rest of people, we are working with different boards. Yeah, so Michael's working on AMDAS, Alex is working on Sailings, and Stefan works on D1 SOC. So Harissa is working on Ziola.
Pete's doing
Yeah.
too.
And Pete is working on G2. So let's make sure we finish everything. Yeah. Herb is working on D0 now. So let's make sure we finish everything within an hour. Because at the 2:30, this lady is going to come to kick us out. So we need to finish everything. Huh? Let's see. I can put this into chat. Yeah, let me put this whole text into chat. Yeah.
Yeah, I got it. Because we sent it to the forum, or I guess it goes to forum or
Okay. Okay, so let me get. Wait, I need to stop sharing screen to send anything. Yeah. So first of all, okay.
Just click on the email. You have the same.
Email.
But if you have some modern error, we can put another model. 1 second. Oh, wait. Okay. Okay, so did you get it now? So now I want to absolutely make sure that everybody does it today.
So I'm getting an error of unrelated business.
Huh?
I'm getting an error of
Okay.
unrelated business.
You are trying to do something strange. Because like, you are trying to do pull request for main using graphics.
No, yeah, we do that too, because, so, yeah.
Okay. First of all, what branch are you in?
New graphic. No, sorry.
Main or new graphics?
New graphic.
Okay, exit from here, do a git branch. Git branch. New graphics. Okay, good. Show me area. First one, okay. So can't open the log file because now this file is called lab specific board config.sh. So just look to Nexus 4. So put another window where you look to Nexus 4 board specific SV. Just see how it is done there. So let me send one more change. So one more step here. So in principle, this exercise illustrates specifically only one feature in Verilog, which is module instantiation. But for some reason, this was not clearly explained in a book schema, just demonstrated. This is very important concept because modules in Verilog is everywhere. So you need to put here lab specific board config instead of simply lab specific config. So let me put it into email.
But D0 had this lab specific config, not both something.
1 second. I have too much echo. Okay. So let's do it with you. So if you want, you can watch how I'm doing this together with Harisa, and then we do this with everybody else. I want to be absolutely sure we do it with everybody. Okay, so what are the commands? Let's do not in parallel, but let's do a sequence. Okay. Wait, why we need to go to that? So the projection as long as it is two tabs, so in one tab you need board specific. So here you need to put last specific board complete. Fine. Yeah, this first line is synchronous reset. We can remove. This first line is not valid. Yeah, so one more you need to remove the okay, done. So first line is okay. Next, screen width, screen height. Yeah, now here, what I want you to do, I want you to align this assignment to the right, because for readability, you want everything to be. Yeah, there are some plugins for system available, so you can put usually I just put my name.
Oh, you do. Okay, well.
I just have such habits, like early age, so I don't do this all the time. Now, next, another thing for readability,
Technically, it's not saying any instruction. You can say.
yeah, like I just said it just now, but that's a lot, you didn't put board. Okay, next thing. For readability, I want to emphasize this screen width. So, so for readability reason, I want to put additional empty line here to separate screen width, screen height, and WX, WY. So just look how it's done in Nexus 4. So go to Nexus 4. Okay, so let's watch boards in Nexus 4. So you see, so here I put, first of all, need to put pixel megahertz here. So get this whole header and just keep this is the same as it was, but put the gas of parameters there. Yeah. No, this is the whole point of this exercise. Even if you don't know idea, just follow it, and eventually you figure out how parameters of the instantiation works. This is like a special type of stupid exercise where you can understand what you did once you did chapter on instantiation and on parameterization. So you need to put pixel megahertz, okay. So put empty line of no, put empty line. We don't need them. Okay, shift A. Shift A, if you're using, yeah. Okay, this thing. Now, so this board has 4 keys, 8 switches, it's okay, 12 LED, 8 digit 7 signal display, so it keeps the same as it was before. So now you put screen width, screen height. And now you need to put here empty line, and now you need to put number of color, width for color channel. So width for color channel, in this case is DP. Because in this case, you need to go down and see how many bits are in here. So here you have only one signal, which is 20 RGB. Which means that you have 1 bit for red, 1 bit for green, 1 bit for blue. So you need to put back here 14 bits of red, green, and blue from there. And 1, 1. Yeah, and you need to put 1, 1, 1. Oh, so in your case, it's different. So in your case, you have a separate signals VGA-R, VGA-G, VGA-P. And you can see that each of them are 8-bit wide. From 7 to 0. So we put 8, 8.
I mean, why do you have to do all this, man? Like, why can't we just declare a DSL on top of like all the things? Like, it seems like we're going like, look here,
This is
accommodate here.
I use it that you want to put here. Yeah. Now you put this declaration to here. So instead of 7, you put here W red minus 1. Yeah, done. Yeah, but now I need to like align, so remove like extra space from here to make everything align. So same thing good for WD, WD. But you don't need to do this.
Okay,
What is
I-
fine.
I think this needs to be 111.
Yes, this should be 1 in your case. In your case, it should be 1. So in his case, it should be 8, because this is different board. Yeah. Like I'm sure that Max has a plugin for value of this. But this might be plugin for value of 95. Okay, so now we like parameterize it. So now let's go down. Down.
Okay, the way I figured out there's 8 bits per color, it's because I happen to look at the code here. But how would I actually know?
If you don't know this code, if you iterate it, you go to file called QSF. So you go to this file is in the same directory. This is called like something like QSF. Yeah, QSF. This is file from a vendor. This actually shows signal, and then you look here and search for a VGA something. Yeah, so here you can see that you have bits for VGA 0, 1, 2, 3, 4, 5, 6, 7. So you figure out from here.
Actually a 3-bit bus, right? And I see the QSF of the Nova, 0, so it's like.
This is a 3-bit bus, but this is common bus for all color channels. Also in his case, he has 3 separate signals. One is red, green, and blue. In your case, you have 1 signal RGB.
Oh,
And this is just the way how different numbers.
I see. So then maybe instead of doing wire, red, green, blue, 3 different, it should just be 1 single parameter.
No, because in our examples, we always operate them as 3 signals.
Okay.
So you need to get 1 signal from this vendor type of signal, and then we split them into 3.
Okay.
Yeah. And here we are doing such like splitting convexity. Yeah.
So, what is the action? This is blue, green, is that
No,
what
this
it
is
stands
this is a pins. They're called on a PGA chip. Chip does not know that this is colors.
Okay.
Chip knows that this is just a wire which goes to the outside wall. And this is from a data sheet of a chip. This is the name of this pin.
for?
Yeah, don't worry. This file you get from a vendor, and this file from vendor maps internal vendors pin names to the symbolic names associated with this board. Okay. Now next. So yeah. So here go down. So what is our next step? Next step is wire. Yeah, but it's wire logically shouldn't be here because they're like out of order. Look at how they are put in Nexus 4.
Okay. It's technically
So-
shouldn't matter.
No. This matter big time because we are not making one solution. We are making something which will be read, maybe not by students but by teachers. So we cannot do a mess of things. Otherwise, they will get lost. We need everything to be in logical sequence. Now, so it should be somewhere. Yeah, it should be. It's here. It's a before microphone and after 7-segment display.
Okay.
So find the same place there. So just to remove this here. Okay. So now hold down. Yeah, so this should be, so here, and by the way, you can put here parameter. No,
W
wait.
there. Oh, this
Here,
is one.
here, everything is correct, because in a VGA module,
Uh-huh.
this port is 4-bit, so we need to convert this 4-bit into 1. We will do this later, but between, put this X and Y here before colors. So, no, not here, but before that. So, here. So here are temporary wires because we need to convert bits. Yeah. In his case, it's a different.
I just left it. That's the wire. It's still fine.
Yeah, but this is fine. There's also ports, and here you can also some internal temporary values. Yeah, okay, now you need to like align this a little bit to put space in space and put empty land there for, so that it's more integral.
Like,
Yeah. Wait, are you sure you like the art?
no, I hate it.
So the root is forward instead, like,
Oh, okay.
okay, press escape. Get out of VI, I understand this VI so many, no, code this, you will just click the code to somewhere here. You just minimize this. It should be code. Yeah, Visual Studio, click on it. Let's go to Visual Studio. And do everything. Yeah, it follows this part is. Yeah, Visual Studio, yeah, this way. Yeah. Now, open folder. Yeah, you can open this one, Word.
No, I was working on my branch.
Good. So go, just open the folder and then you can file in this folder. You can see two files. Yeah, just open it, just. Open. Wait. What? What do you think?
No, I,
Oh, okay, now, open folder, yeah, okay, open, okay.
and then navigate.
Now, you can get the file next is for. So, the board get file next is for. So open this, now in a different tab, open your file, which is 0. Why are you opening file? Don't
Because
open file,
okay, okay.
because it should be in the same area.
No, but I don't know if it was the right,
Huh?
because I don't,
This is the one that's good before. That you think so?
Yeah, this is, I don't know.
no,
Next
this
is,
is fine.
next is
Oh,
good.
yeah.
So now let's see yours.
0 1.
Yours are in 0.
Yeah.
Yeah, so 0 is here. Okay, so now.
Okay,
Yeah,
okay.
this is right. Yeah. So this is right. So now, you.
That's the right one. Okay, okay, okay.
Yeah, okay, so where's your insert? There's no insert price. You insert? No.
Yeah, no, that's because, okay, that is because we have to go to I clone new graphics into another folder.
In this case, just to get the. new
That's why,
folder.
let's just go to the actual folder, that's why I was trying to do that.
Let's open, yeah, let's open
Okay,
the
let's-
whole
let's
folder
go
where
to
is the
my-
most. In here? So, you can use the microscope in there to figure out where the things are.
Yeah, no, I found this.
You should have.
I'm pretty sure this, no, pretty sure.
Because this is the last time you connected it in the wrong way, because when you, power didn't turn on,
Yeah.
should there's some protection.
No, I had one. I
Yeah,
had one. Yeah,
Okay, so you know what to do, right?
We only got one remaining problem, is lab LED.
No,
Yeah, well, let's finish.
Why am I not able to open? Through at the same time and include separate tabs?
Usually I don't know.
Okay.
I have not done
Just think to one and another, I'm sure you can know.
No.
Okay.
All right, so next is zero. Okay, it's fine.
Usually it goes to you messed up. But you know, you can know for the second instance of code.
It's definitely.
Okay, so now put wire X and wire Y. You put over the,
I did X and, okay, so,
yeah, now,
sorry, one thing. So I did wire X, wire
yeah,
Y.
okay, this is fine.
Okay,
So you also need to align everything here in this space. Also in nice neat ways, so that people can be in. So look to Nexus, how this is done in Nexus, do the same thing. Look at how this is done in Nexus. If the Nexus, there are some additional lines, which is sometimes put and sometimes don't, and create there.
why is next to the cell? No, next to, yeah, I know, what's not for?
This means that you went to the wrong branch. You go to the main branch,
Okay,
or you didn't fetch it. You didn't fetch it, you need to do, get full in a branch, or you went to the main branch, something.
Like, I don't want to do looking at one that doesn't have that stuff.
Mhm.
Right, if you think you actually did that comment on that one, right? Let's just switch the branch over to the same branch. Now, you have two copies of stuff, right? A little copy,
Yeah.
right? And you have one branch, thing. Let's just switch that other branch to also be the, you know, do whatever.
So you got it, so not confused.
Okay, I'll just finish the board edits first, because what matters is having lines and zero.
Are you? Okay, so this is Nexus. So in Nexus. Yeah, so you see in Nexus, I also put empty, the empty line here and here, so that reader can clearly see screen width, screen height, red, green, blue. So I logically grouping this parameter here.
Hmm. 13 items. Hmm.
It was only there from the. Yeah. Yeah, that's it, I told you. Yes. For the X here. Yeah. Implementation of it. And then there should be some. So yeah, you need to relearn. Yeah, because. No, last one, no problem. No, yeah, like here you don't have formula, right? After blue you don't have, so last one, no formula. I think we have no formula. We think for you, which editor is it? So, you're not saying that. Oh, wait. Okay, now I have the, oh, let's make sure that this is the right place. Okay, after this, and this, okay. Yeah. That is all the changes.
Because there's no board, the same thing that is on yours, I think it's a wrong board.
No copy. Okay.
Board is a board.
Oh, I'm sorry, I'm running this on the wrong place. Okay.
So. But it's, so, do you understand? But it's done. Huh? Yeah, in this case, it's better if you sit there, just follow her and see what she's doing. It's the same thing to you. Okay. This is important exercise because you learn how to deal with the module kind. Right.
I did my code change. I did my code, code in the main branch, but the place where you run the rectangle, ellipse and so on, that's the new graph. Copy it into the new graph. Okay, sure.
Copy all changes in the graphics branch. Just make sure not to check the information.
Okay. I think you need to remove it.
Oh, we just, yeah.
And then the dot X.
That one, I don't know.
Yeah, that's fine.
Oh.
It has to do with, right? Every time you add something.
I'm, are you, is this include the letter, this file, or?
I think it's similar to like Python, include very just include this file. So whatever, even I'm very new to it. So I think it's like whatever is there on this file, you already have access to it. Like you can probably call functions from that file in this.
Yeah. Yeah, I know, yeah, okay,
Or, yeah.
whatever,
Even if VG, for instance, is I think.
okay, okay.
The model that we have. Okay.
So did your error?
It's now a different error, so I copied it over and declaration errors can't declare implicit next because the current value.
Both is fine. Okay. So here, you can learn because we call it model, but this model is different words. So what we need to do now? Which is simple do you have? Volume, color, not your color, not your, the top of the volume. So, go down. So here, you can see this. VG8 VG8.
Yes, and
Which is there. And you have VG RGB. So you need to, so there are temporary wires here, but you need to put the temporary wires. So go down. Yeah. And put here this like temporary, no, stop.
Okay.
This is fine.
No, sorry, over there, it's all everything, we can, should not.
Yeah, so put 8 sync V-sync, so put here different thing, here, 8 sync V-sync. Everything on V-sync.
So there was a mismatch.
Okay, so now try it.
And something even about one.
Yeah, no, it should work, so just like that. Oh, yeah,
Not blank thing.
so go to do the CVG button. I think that we don't have blank signals yet.
Yeah,
You can just line. And you move every line. And you move this every line, yeah, down.
and this is fine.
No. Go back.
Okay.
And you won't get good space. You should, it's not connected. Because this board, you don't have.
Okay, so remove this line.
No. I don't think.
Okay. So remove
The
the.
space is itself. You don't need to look in space. It's a, this board exists, but it's not connected. It's not there. Yes, it's okay. This is a purely mechanical and stupid exercise, but it does efficient.
Yes, I agree. I think I need a real stand up.
Well, this one has a lot of different combination of the code. Because all preparation, where is VGHs, VGHs? Fine. You do say, but you do copy to the right place.
Yeah.
Pero tiene que estar correlacionado, ¿no? Porque el dispositivo es el que lleva la referencia y
I didn't want to remove any extra filters of any code because you get confused then if you say the one place we have another.
Yeah, I'll delete this directly altogether. After that, I'm done.
tú tienes una salida de una salida de ¿no? Te la mando a la web. Y la otra son los 12 bits de toda la resolución que tienen los 12 bits de masa, ¿no? Bueno, sí, ejemplo que tengo, yo digo que era 4 bits, 4 bits, 2.
George?
Yep.
So can you help Alexis to give this savings board?
Well, right, it's one that's about we need to do it, actually,
If you follow what you're doing there, you understand.
Okay, I'm over that.
So you have to learn syntax of instantiation, syntax of parameterization. You know, syntax of signal declaration, and then you need to understand the concept that you move instance from one place to another. People have these wires. It's like mechanical exercise, but you learn a lot of very long syntax and semantics.
How close is
Yeah,
from the last week?
just the same, but last week we did it for a different board.
That's correct.
Ah, it was board G10, and this is different board. So it's a different file with somewhat different how signals. Oh, okay, but it's the same.
Now it's one. And you know,
Yeah,
The same thing we did last week. Different board.
same thing, but it's different board.
Entonces, para menos peligro. But all I've done is.
I think so. I think.
You're really solved the combination.
Yeah, yeah.
What was that? The problem?
That problem was I was including the wrong file. I think it's board specific, lab config something. It was working with the begin. Okay, let me get rid of the. That's what I found.
Okay, now.